There's an animal in the ocean that can tell you apart from someone else, even if you're both wearing the exact same clothes. It can remember which person fed it and which person poked it with something sharp weeks earlier, and it will treat you differently the next time it sees you, based on that memory alone. That animal is the octopus. And on paper, this shouldn't really be possible. An octopus doesn't have a face-processing brain region like we do. It doesn't have anything close to a human visual system. Its entire body plan is about as far from ours as you can get in the animal kingdom. So how is it recognizing individual people well enough to hold a grudge? Let's start with what researchers actually tested, because the setup is simpler than you'd expect. In controlled studies, 2 different people took turns interacting with the same octopus over several weeks. Both wore identical clothing, so there was no obvious visual cue like a certain shirt color to rely on. One person consistently fed the octopus. The other person consistently did something mildly unpleasant, like gently touching it with a soft object it didn't enjoy. After enough repeated sessions, the octopus started reacting differently to each person the moment they walked up to the tank, before either one had done anything at all. It reached toward the person who usually fed it, and it would squirt water at, or actively avoid, the person who usually bothered it. That's the part that matters. The octopus wasn't reacting to what someone was currently doing. It was reacting based on memory of what that specific person had done before, and it was somehow telling 2 people apart well enough to apply the right memory to the right individual every time. So how does an animal built so differently from us actually pull this off? The first piece of the answer is the octopus eye itself. It works in a surprisingly similar way to a human eye, with a lens that focuses light onto a layer of light-sensitive cells, even though octopus eyes evolved completely separately from vertebrate eyes on a totally different branch of the evolutionary tree. This is one of the clearest examples of convergent evolution in the entire animal kingdom. 2 completely unrelated lineages arriving at a very similar design because it happens to be an extremely effective way to process visual information. So right away, the octopus has genuinely sharp vision to work with, capable of picking up on fine detail. But sharp eyesight alone doesn't explain memory and recognition. That comes down to the brain, and this is where things get strange. An octopus brain contains somewhere around 500 million neurons, which is a lot for an invertebrate, but the structure of that brain is almost nothing like ours. A huge portion of those neurons aren't even packed into the central brain at all. They're spread out through the arms, letting each arm process information and react on its own, semi-independently. While the central brain focuses on bigger picture tasks, like remembering a person's face and deciding how to react to them. That central brain, even though it's built completely differently from a human brain, still seems to be capable of forming detailed, lasting associations between a visual image and a specific outcome. See this person, remember they fed me. See that person, remember they bothered me. It doesn't need a brain structured like ours to pull that off. It just needs enough processing power dedicated to memory and pattern recognition, wired in its own unique way, and it turns out that's exactly what an octopus has. It's also worth ruling out the simpler explanation, because the first guess a lot of people have is that the octopus might just be smelling the difference between 2 people rather than actually recognizing a face. Octopuses do have a strong sense of taste and smell through their skin and suckers, so this was a reasonable question for researchers to ask. But the recognition held up even when researchers controlled for scent as much as possible, and the octopus still reacted the moment a person came into view, before any physical contact happened at all. That timing matters. A reaction that happens on sight before touch or smell comes into play points much more toward actual visual recognition than toward some simpler chemical cue doing all the work. There's also a strong incentive for this kind of recognition to exist in the first place, and it comes down to how octopuses actually survive. In the wild, an octopus has no shell for protection and relies almost entirely on intelligence, camouflage, and quick decision-making to avoid becoming someone else's meal. Being able to tell threats apart from non-threats, and remembering which specific animals or situations led to danger before would be an enormous survival advantage. The same mental skill that lets a captive octopus recognize a specific person is very likely a direct extension of the same system it would use in the wild to remember which predator or which part of the reef previously caused it trouble. This also connects to something else researchers have noticed. Octopuses in captivity often develop what looks a lot like individual personality. Some are consistently more curious and willing to interact. Others are consistently more defensive or cautious, even when raised in nearly identical conditions. If an octopus is capable of forming lasting memories about individual humans and reacting consistently based on those memories, it makes sense that its behavior would look less like a simple animal running on instinct and more like something closer to an individual with actual preferences, shaped by its own specific experiences over time. So put this all together. Eyes that evolved independently but ended up remarkably similar to ours. A brain built on a completely different structure, yet still capable of forming detailed, lasting memories tied to specific individuals. And a survival history in the wild that would have rewarded exactly this kind of recognition for millions of years before an octopus ever ended up in a research tank. The octopus didn't need to look anything like us or think anything like us to end up with the ability to remember your face. It just needed a brain good enough at pattern recognition and memory, built its own way, and evolution got it there anyway.